So let us talk about grid computing today. Grid computing is a type of data management and computer infrastructure designed as a support primarily for scientific research, but also used in various commercial concept, business research, entertainment, finally by government of different countries. Now, this definition you can say, or the idea about grid computing, it involves heavy scientific research. Why it is there? Because people have been using it for quite some time now. Government and international organization, military, teachers, educators, and businesses. How this works? There is a grid server. There is a grid of computer or computers running on a special grid. These are on some network software. So there are network software, and we have a software called middleware. There are in general, if you talk about grid, these are the users. Okay, you are the users. Now you have to go to a grid server. This grid server eventually takes you to the grid clients, which are actually in network. Grid is like this. Simply, I'm just giving a layman definition. This is like grid. So if your computers are like this, managed and placed in some form, but you are not aware of how they are managed, this is a prerogative of grid server. So this is how grid computing works. And grid is this, and computing is also there. What is computing? Whatever you want, maybe in research field or scientific field, you want something to be computed fast, distributed to various clients. This is grid computing. Now it has a very much similarity. It has a great similarity with the other computing which I'm going to take on just now. But before that, let us see how exactly your request goes, how your processing is done. So this is where you are giving a result or a computing result. The user sends computation or data intensive application to global grids in order to speed up the execution of the application. Now these grids are not at your local level. They may be anywhere. You are not aware of it. Who is actually doing it? The resource broker. The resource broker distributes the job in an application to the grid resources. These are the grid resources, and these grid resources may be cluster, may be PCs, may be supercomputers, may be database instruments. So these are the global grid which execute your job, that is the user job. Now this resource broker is giving or distributing the job to the grid resources based on users' quality of service requirement and detail of available grid resources for further execution. First of all, what user require, and second thing, where or what form these grids are available. Now these are the computational jobs which are given, and after computation this grid returns the process job and which is given back to the user. Now in between there is a grid information service. From here, details of grid resources are given to grid information resources or services. This system collects the details of the available grid resources and passes the information to the resource broker. This is how resource broker is knowing that what all grid or how the grid is available to us, or which grid to be allocated to which user in depending upon the quality of service requirement. This is the grid architecture. Fabric layer is there, connectivity layer, resource layer, collective layer, and application layer. What is this fabric layer in the grid architecture? It provides the resources to which shared access is mediated by the grid protocols. And connectivity layers, the name suggests connectivity. So it defines the core communication and authentication protocol which is required for grid specific network functions. Then this is a resource layer. What it does, it defines the protocols, the APIs, the SDKs for secure negotiations, initiation, monitoring, control, accounting, payment of sharing operations on individual resources. And this collection layer, again the name suggests, it contains the protocol and services that captures interaction among collection of resources. Then comes the application layer. This is where you are. So these are user applications that operate within that environment. This is the grid security model, because actually you are transferring, or you are throwing or giving your data or information to certain systems which are doing your computation, and this is on internet or your network or whichever way, because you have to give it to some other system. For that you require a great grid security. So this is the grid security model. You have secure conversation, maybe credential and identity management is there, access control environment is there, audit and non-repudiation is there. So there has to be an intruder detection, antivirus management, policy management, user management, key management. These are various policies and rules which are being applied, and these are policy expressions and exchanges, and these are the binding securities. So this is the grid security model. There are various types of grid. I'm going to give you idea about type of computing also. So first, just let us see that what are the types of grid which are available, and these are broadly divided into three types. First type of grid is computational grid. Second is your scavenging grid. Third is your data grid. So what is a computational grid? This computational grid is focusing on setting aside resources specifically for computing power. So if required for high computing, computational grid is there. So in this type of grid, most of the machines are high performance server. So specifically high performance server for computing power, it gives a great computing power. That is why it is called the computational grid. Then comes the scavenging grid. This scavenging grid is most commonly used with large number of desktop machines. So we don't have high computing power here, but we have a grid of desktop machines. These machines are scavenged for available CPU cycles and other resources. So owner of the desktop machines are usually given control over when their resources are available to participate in the grid. Then we have data grid. This data grid is responsible for housing and providing access to data across multiple organizations. So users are not concerned with where this data is located as long as they have access to this data. What is grid computing now? This is very important questions. You have computational grid, you may have homogeneous like clusters, you have heterogeneous. And there are various cousins of grid computing. There are various methods of grid computing. Let us see one by one, each of them. So computational grids, as we suggested, the network of geographically distributed resources including computers, peripherals, switches, instruments and data. So each user should have a single login account to access all resources, and resource may be owned by diverse organizations. The grids are typically managed by gridware. Again, a new name for the middleware. So gridware can be viewed as a special type of middleware actually that enable sharing and manage grid components based on user requirements and resource attributes like capacity, performance and availability. As I suggested, there are cousins of grid computing. Why cousins? Because they are in one form or the other somewhere related to grid computing. Parallel computing, distributed computing, peer-to-peer computing and other computings like cluster computing, network computing, client-server computing and internet computing. Distributed computing. So I was indicating in just a few minutes earlier that grid computing is often confused or often synonymized, say that this is similar to your distributed computing. But the answer is no. Distributed computing is most often concerned with distributing the load of a program across two or more processes. So if we distribute the load of the processing to two or more or many processor, you are distributing the load of computation basically. This is how distributed computing works. But this grid computing is not only about computing. It is about having or giving the data to a proper grid structure where you have a formalized architecture. And this is peer-to-peer computing, sharing of computer resources and services by direct exchanges between systems or two systems direct. Computers can act as clients or servers depending on what role is most efficient for the network. Now coming to methods of grid computing, say distributed supercomputing, high throughput computing, on-demand computing, data-intensive computing, collaborative computing, and logistical computing. These are all the methods of grid computing. This is how your distributed computing find its difference from grid computing. Distributed supercomputing, combining multiple high capacity resources on a computational grid into a single virtual distributed supercomputer. So it tackles the problem that cannot be solved on a single system. High throughput computing, it uses the grid to schedule large number of loosely coupled and independent tasks with the goal of putting unused processor cycles to work. So when high throughput is required, then this type of computing is generally used. Then on-demand computing. It uses grid capabilities to meet short-term requirements for resources that are not locally accessible. That is, it is available on demand, so models real-time computing demands. And data-intensive computing, the focus is on synthesizing new information from data that is maintained in geographically distributed repositories, digital libraries, and databases. So particularly useful for distributed data mining. So if you have intensive data computing like data mining or similar technologies, then you use data intensive computing. Then collaborative computing. This is concerned primarily with enabling and enhancing human-to-human interaction. That is why it is known as collaborative computing. So applications are often structured in terms of virtual shared space. Then comes the logistical networking, global scheduling and optimization of data movement. So contrast with traditional networking, which does not explicitly model storage resources in the network. So logistical means keeping your logistics. So this is called logistical because the analogy it bears with the system of warehouses, depots, and distributed channels. So what are the advantages? Increased user productivity, first of all. By providing transparent access to resources, work can be completed more quickly. The scalability is always there. Grids can grow seamlessly over time, allowing many thousands of processors to be integrated into one cluster. And flexibility. Grid computing provides computing power where it is needed most, helping to better meet dynamically changing workloads. But there are a few disadvantages also. For memory-hungry applications that can't take advantage, you may be forced to run in a larger system. You have to go to a larger system from a smaller system if memory-hungry applications are there. You need fast interconnection between these computer resources. For example, gigabit Ethernet is sometimes very much wanted, and some applications may need to be tweaked to take full advantages of new model. And licensing, this is very important. Licensing across many servers make it prohibitive for some apps. So vendors are starting to be more flexible now with environment like this. So grid computing introduces a new concept of IT infrastructures because it supports distributed computing over a network of heterogeneous resources and is enabled by open standard. So heterogeneous for if you want heterogeneous resources to be used, and open which are guided by open standards, and you want some distributed computing, then grid computing is very useful. Thank you so much. Take care.